Okay, in this video what I'm going to do is work through the linear regression example that I posted within this week's learning module in Blackboard. What I'd like you to do is show you how to do this in Jump. We're going to have to break this apart though, because there's a lot of different pieces to this question. In this first video, I think I'm just going to worry about part A, which deals with how do you create a scatter plot in Jump and find Pearson's sample correlation coefficient, so you could kind of have an initial gut feeling on whether you feel that the data you're looking at is in fact linear, and the type of linear trend it has, as well as how strong the bond is between the two variables. All right, so let's give a look. It says a marketing executive is trying to decide how close the bond is between sales of their product and advertising. The table below lists the varying sales according to the amount spent on the advertising of his company's product. X represents advertising dollars in thousands, and Y is sales. All right, so as you can see, the data table. Okay, so there it is. There are 12 pairs of data, as you can see. Remember, the data is matched together, so when they spent $5,500 in advertising, there was $100,000 in sales, and so on and so forth. All right, so what I'm going to do right now is show you how to work this in Jump. So it says letter A, use your calculator. All right, well, I use the same example face-to-face with my students, and we use a TI calculator a lot of the times in class. So we're going to use Jump, actually. So use Jump to make a scatter plot that shows how advertising dollars explain sales. Does there appear to be a linear relationship? Find the Pearson sample correlation coefficient, and what does R tell you about the strength of the relationship? All right, so I'm going to show you my go-to, what I usually use here. So I've already entered the data into a new table in Jump. Remember, if you want to do that yourself, you would go File, New, and you would select Data Table. And when you do that, it creates a blank table for you. And then, of course, you could import the data into the table, copy and paste. One nice little feature I do like to do, because, when you're looking, if you're copying and pasting data, which is kind of nice, like when you have it electronic like this, naturally, you can highlight this column. Don't forget this column is continued over here. But you could highlight the column with its title. And one of the nice little paste features in Edit is paste with regular paste, and I wouldn't use that option if I copied the column name, because then what it would do is it would take the column name advertising and it would probably put it in the first field right here, number 1, and then you'd be mixing categorical data with continuous data, and then the Jump wouldn't understand that, and it would give you a different label over here on the left. That little blue triangle lets you know that the data was inputted as a continuous variable. So one nice little feature in Edit is paste with column names, and then it knows that first row actually is the title of the column, and it'll put it in that spot. All right, so when I'm going to create a graph for the scatter plot, it depends on how much more analysis I'm going to do after that. Don't forget, I'm teaching this stuff a lot, and like right now, I just want to talk about, hey, how do I create the scatter plot, and how could I find Pearson's correlation coefficient R? So in that case, if I'm not going to go any further than that, I do like to use the graph builder. But there's two menus here that I use for this scenario. I use the graph builder. In graph, there's this first option here, graph builder, and then there's another analyze fit Y by X option we have. So let's look at them one at a time. So I'm going to go graph and use the graph builder. Now the graph builder is great because you just kind of drag and drop your variables into the drop zones, and it works really well. So if you look, there's this drop zone over here for the Y variable. It says when you hover over it with your mouse, it tells you place the Y axis variables here, and then for the X, place the X axis variables here. All right, so it's pretty basic. So the X axis, remember the guy's trying to make a decision on, depending on how much money I spend on advertising, does that affect my sales? So for the X variable, which is advertising, I'll drag that into the X category. So there it is. And then the sales, naturally, I'll drag into Y. And when you do that, it automatically builds you a scatter plot. Now, the default for Jump is to also add this what they call the smoother in there, and you could tell that that's the case right here, because up top you have all these different menu items. So if you uncheck, unhighlight this button right here, click it, it'll remove the smoother. And one thing you could do if you'd like is you could add the regression line on there. Now the regression by default also fits a confidence interval into this blue band. So this is something we're going to talk about next week. So for now, I could turn it off if I'd like. See, it says confidence fit. If I uncheck that, it'll actually go ahead and take that out. All right, so that's one thing you could use. Now, another thing I like to do is to put the overlay the density ellipse on there. And remember, if in your reading this week, you saw that if data in fact is linear, that it has this football shape to it. JMP has that, the football shape. That's a loose term mathematically, obviously. The actual terminology is called a density ellipse, and that's the very next box, as you can see this one here. So if I check that, it creates a density ellipse. And as you can see, well, let me do the coverage for 95%, which would kind of be a default for most people. You can see the majority of the data lies within this density ellipse. Now, what is, how do we interpret the density ellipse and how do we get the density ellipse? That's something we have to still talk about. That's up and coming. For now, you can see the density ellipse does contain the majority of the data and does in fact look football shaped. We do have this guy down here, which is kind of messing us up a little bit. That would maybe make us question what's going on here. But again, these are things that we have to talk about that are up and coming. And one nice little feature right here, right under this where I switched the coverage to 95% is the correlation. If I check that box, as you can see, it tells me Pearson's correlation coefficient, which is about 0.89. All right, so this is kind of my go-to. I really like to, use the graph builder, pop the variables in. I like to select the density ellipse, and then I check the correlation button, and it shows me Pearson's R. This is a quick check to say, hey, the data does look like, in fact, it is linear. It is going up. There's a positive linear correlation, and that R value is pretty high, 0.89. It's, by the way, it's high for a couple of reasons. It's really high because, it's a textbook example, naturally. It's not like it's, thousands of pieces of real data, data that were collected in the real world. So it's kind of like a model problem for a textbook. Most correlations in the real world aren't going to be about 0.9. They'll be a little bit lower than that. But this is kind of my go-to. Now, what else could you do? Well, that same menu is, believe it or not, in the Analyze Fit Y by X menu. So if I select that, very similar, as you can see. I kind of like this little legend down here that lets you know what type of graph it would calculate based on what's the variables, what were they recorded as. And when you look at your data, you can see the variables were recorded as continuous. That's what those little blue triangles mean. So, and you can see a blue triangle and a blue triangle. That's going to be a bivariate scenario. And you can see what the other cases would be if you went to, categorical or nominal data or what have you. Again, same deal. Grab your X data, put it in X. Grab your Y data, put it in Y. So advertising, remember, was X, and sales was Y. So I'll say OK. And as you can see, it creates a scatter plot, and it's the same scatter plot as the one that we just created a minute ago. So let me blow this up so we can see it a little bit larger. And then there's this little red triangle here. If I click that, I could say density ellipse. Same density ellipse. And if you click that little triangle, as you can see, it shows you the correlation as well. It also, which is kind of nice, calculates the mean and standard deviation of each individual variable. In other words, this guy spent about 6.266 thousand on advertising, and his average sales were about 115.75, and it gives us standard deviations as well. Now, it gives you significance probability. All right, well, that's something we still have to talk about. There's a hypothesis test that goes along with this, naturally, that it tests the significance of this correlation. And that's going to be in, I believe, in week 11, I think it is. All right, so let's go back to the question and answer what we have here. So it says, Use your calculator to make a scatter plot. Okay, we did that. Does there appear to be a linear relationship? All right, so obviously, yeah, we could see. So for letter A, we would say yes. There appears to be a strong positive linear relationship. This is shown from the fact that R is about 0.89. 0.89 as a correlation value there lets you know that this is a strong positive correlation. So I believe that answers all the parts. Does there appear to be a linear relationship? We answered that. Find Pearson correlation. We did that. What does R tell you about the strength? Okay, yeah, so we've answered all of those parts. All right, so I'll answer the rest of these questions in a separate video. But if you have any questions on, how do you create the scatter plot and find this correlation, send me an email. Thanks for watching.